Imagine for a second that every moment you have ever lived, every moment you will ever live, and every moment the universe has ever experienced is happening right now, all at once, in a single frozen block of reality where time isn't moving forward, but is just a trick your brain plays on you to make sense of the chaos. We are talking to we are about to walk into the strangest room in the house of science. This is the room where we take the clock off the wall and throw it into the trash. The subject here is the Wheeler-DeWitt equation, which sounds like a scary name, but it is actually just a description of a universe that doesn't change. When we look at the world around us, we see things moving. A car drives down the street, a leaf falls from a tree, you take a breath in and let a breath out. All of these things require time. You need a before and an after for any of them to make sense. But there is a very specific, very serious view in physics that suggests the whole universe, the entire thing from Big Bang to the very end, is already finished. It is already done. It is just sitting there. Think of it like a DVD movie disc. If you hold a DVD of a superhero movie in your hand, the whole movie is in your hand at once. The beginning where the hero gets powers, the middle where they fight the villain, and end where they save the day. All those moments exist simultaneously on the plastic disc. They aren't happening one after another on the disc. They are just each etched there. The time only happens when you put it in a player and watch it. This first slide sets up that exact idea. The universe is the DVD. It contains all the events, but it isn't playing. It is just being. The strange symbols you see, like the H and the Greek letter psi equaling 0, are just the mathematical way of saying the total energy in the universe is 0. It means nothing moves, nothing ticks. The clock is broken, but the picture is perfect. We are going to look at how a universe full of motion can actually be a universe that never moves at all. We call these two men the wizards of this story because they took the standard rule book of physics and cast a spell on it that made time disappear. John Wheeler and Bryce DeWitt were serious scientists, not fantasy writers, but they asked a question that sounds like a riddle from a fairy tale. They asked, can the universe tick without a clock? To understand why they asked this, you have to realize that usually science loves clocks. Almost every formula we use to describe how a ball throws or how a planet orbits involves the letter T for time. We want to know where the ball is after 1 second or 2 seconds. But these two thinkers looked at the biggest picture possible. They weren't looking at a ball or a planet. They were looking at the whole container. They looked at the entire cosmos. And they realized something bizarre. When you try to apply the rules of the tiny quantum world to the entire massive universe, the letter time, T, drops out of the equation. It just vanishes. It is like baking a cake and realizing the recipe doesn't mention flour. Even though you thought flour was the main ingredient, they found that the universe doesn't seem to need an external clock to exist. Think of a music box. Inside, there are gears turning and a cylinder spinning to make a song. That needs time to work. But if you look at the music box sitting on a shelf from the outside, it is just a box. It is a simple object. Wheeler and David were looking at the box from the outside. They realized that while we, the little gears inside, feel like we are turning, the box itself is just sitting there. They were the first ones to realize to really take the math of the super tiny and wrap it around the super huge, and the result was a universe that is timeless. It is a startling idea. It suggests that now is just a coordinate, like left or right, not a fleeting moment that disappears. Before we can understand a universe without time, we have to understand the weird rules of the small stuff. We are going on a journey that takes us away from our big, clumsy world of toaster ovens and school buses and down into the basement of reality. The map shows us the path. We start at the island of tiny things. This is because the rules of the timeless universe come from quantum mechanics, which is the study of atoms and particles. You cannot understand why time stops until you understand how matter behaves when it is extremely small. Then we move to ocean of waves. This isn't water. This is the idea that stuff isn't solid. In our normal life, a rock is a rock. In the quantum world, a rock is a hazy cloud of possibilities that acts like a ripple in a pond. Next is the jungle of jumps. This is where things teleport. In the big world, to get from your bed to the room, to the door, you have to walk across the floor. In the quantum jungle, you can be in bed and then suddenly be at the door without ever touching the floor in between. Finally, the sky of sums. This is where we add it all up. We are building a ladder. We start with an atom. We see it act like a wave. We see it jumps without time. And then we realize the whole universe is just a giant version of that atom. It is like learning how one brick works so you can understand the whole castle. If the brick is red, the castle is likely red. If the atom is timeless, the universe might be timeless too. We have to walk this path step by step because our brains are trained to believe in time. We rely on time for everything. We unlearn To unlearn time, we have to go back to the basic building blocks and see that they don't wear watches. Let us look at the stuff you are made of. Imagine a giant castle. It has towers and flags and windows. If you get closer, you might see it is made of bricks. If you built a version out of plastic blocks, you can see the individual bumps on the blocks. Now look at a grain of sand. To your eye, it is just a speck, but if you blew that grain of sand up to the size of a football stadium, you would see it is made of even smaller things called atoms. And if you blew the atom up, you would see mostly empty space with tiny particles zooming around. Here is the secret about these atoms: they don't age. A stone crumbles over time, a piece of fruit rots, a car rusts, but the atoms inside the stone, the fruit, and the car do not get old. An electron today is the exact same electron from 10 billion years ago. It doesn't have wrinkles, it doesn't move slower, it is just is. This is our first clue that time might not be what we think. The fundamental pieces of reality are ageless, they are eternal. Think of them like the alphabet. You can write a new story or an old story, but the letter A doesn't get old. The letter A is just a shape, it is a permanent tool. Atoms are the alphabet of the universe. They are zooming around, dancing, spinning, but they aren't wearing down. They don't need a break, they don't sleep. The motion inside an atom is a special kind of motion that doesn't lose energy. It is a forever dance. If the building blocks of the universe doesn't really care about the passage of years, maybe the universe itself doesn't either. The electrons are buzzing like fireflies that never burn out. Now we have to change how we picture these tiny particles. We usually think of an electron like a tiny marble or a little ball bearing, but it isn't. It behaves more like a ripple in a pond. If you throw a stone into water, rings of disturbance spread out. That shape, that ring is a wave. It carries information. It tells the water at the edge of the pond that a stone fell in the middle. The universe is full of these waves. Light is a wave. Sound is a wave. The important thing about waves for our timeless story is that a wave is a shape that exists across space. Think of a jump rope. If two kids hold a rope and wiggle it, a wave travels down the rope. The rope itself stays in the kid's hands, but the shape moves. In the Wheeler-DeWitt view, we stop looking at the movement and start looking at the entire rope at once. If you took a photo of the squiggly rope, you would see a wave shape. You don't need to wait for the wiggle to move to see the curve. The curve is right there in the photo. Sound works this way too. When you speak, you push air. That push bumps into the next bit of air, like dominoes falling. But if you could freeze the air in the room while you were singing, you would see a pattern of thick air and thin air filling the room. It would look like three-dimensional sculpture of sound. That sculpture exists even if time stops. The pattern is real. The universe might be a giant, frozen sculpture of waves. We think the wave is moving because we are riding along it like a surfer, but the ocean itself, the big collection of all waves, is just sitting there, holding every possible shape it can hold. This is where things get really weird. In our big human world, you can only be in one place. If you are sitting in a chair, you are not standing by the floor. If a soccer ball is to in the net, it isn't in the middle of the field. That is the rule of big things, but tiny things like atoms break this rule. They love to break this rule. A tiny particle can be in two places at the exact same time. It can be in on the left side of box and on the right side of the box simultaneously. This is superposition. Imagine if you had a superpower where you could sit at the desk of your school and be playing on the swing set outside at the very same moment. Not a clone of you, but you, the one single you, occupying two spots. It sounds impossible, but atoms do it every day. They exist as a cloud of possibilities. They are sort of here and sort of there. They don't pick a spot until they bump into something or are measured. Why does this matter for a timeless universe? Because it means reality isn't a sharp single point, it is a smear, it is a spread out haze. If the universe is made of these things, then the universe itself is a giant smear of possibilities. It isn't just one story happening, it is all stories happening in a ghostly overlay. Superposition tells us that being is more important than moving. The particle simply is in multiple states. It doesn't need time to run back and forth between the two spots to look like it is in both. It is just inhabits both. It is like a ghost that haunts the whole house at once. So, how do we keep track of a particle that is in two places? We use a map called the wave function, but this isn't a map of streets and houses. It is a map of maybes. Imagine a cloud floating over a playground. The cloud is thick in some spots and very thin in others. If the cloud represents where a child might be hiding, a thick, fluffy part of the cloud over the slide means there is a really good chance the kid is on the slide. A thin wisp of cloud over the swings means there is only a tiny chance the kid is on the swings. This cloud is static, it is a shape, it describes the likelihood of finding something. In quantum mechanics, everything has this cloud. You have a cloud, your dog has a cloud, the planet has a cloud. It is a mathematical shape that tells us the probability of where things are. The interesting thing is that until you actually look, the cloud is the only thing that is real. The particle isn't in the cloud, the particle is the cloud. It is smeared out over the slide and the swings. This connects to the timeless idea because a probability map doesn't necessarily need to change. You can have a map of probabilities that sits perfectly still. Think of a lottery wheel before you spin it. The wheel has a slice for $5 and a slice for $100. That layout is a wave function. It tells you the odds. The wheel is a static object. It contains the probabilities of winning or losing, all held together in one circle. The universe is that wheel. It holds all the chances, all the maybes in a frozen, silent structure. Now take that cloud map we just talked about, the one that shows where a tiny electron might be, and make it bigger. Make it the size of a room. Now make it the size of Earth. Now make it the size of entire universe. This is the universal wave function. This was the big idea of Wheeler-DeWitt. They said if an atom has a wave function and the universe is made of atoms, then the whole universe has one giant wave function. This giant cloud contains everything. It contains the stars, galaxies, house, breakfast, everything. But remember, it is a map of possibilities. So this giant cosmic cloud contains every possible version of the universe. It contains a version where you ate toast for breakfast. It contains a version where you ate cereal. It contains a version where Earth never formed. It contains a version where dinosaurs still exist. All of these are bumps and thins in the giant fog of the universe. And here is the kicker, this universal wave function doesn't change. It satisfies the equation h psi equal to 0. It is a fixed eternal object. It creates a multiverse of possibilities that all exist at once in a timeless crystal of reality. Imagine a library that contains every book that could ever be written. The library isn't being built, it is already finished. All the books are on the shelves. You might read them one by one, but the library itself is stationary. That is the universal wave function. It is the library of everything, standing still forever. This is the best way to understand how the universe can be finished, even if we feel like we are living in it. Think of a coloring book. When you buy a coloring book, the picture is already there. The outlines of the dragon, castle, and the knight are printed in black ink. The story of the picture is already told. The dragon is definitely flying. Knight is definitely raising a sword. That outcome exists before you even open your crayon box. Now you start coloring. You color the dragon green, you color the sky blue. You are moving your hand, taking time, feeling it bit by bit. To you, the picture is becoming real. But the page itself, the structure of it, was already complete. In the Wheeler-DeWitt universe, the blank outlines are the laws of physics and the structure of reality. They are all there. Past, present, and future are all drawn on the page. We are just a consciousness coloring it in. We experience the dragon's tail first, then the wings, then the fire. We feel a sequence, but the page doesn't have a sequence. The tail and the head exist simultaneously on the page. If you were a tiny ant walking across the page, you would say, "Oh, look, I found a tail. I wonder what comes next. Oh, now I see a body." You would think you were discovering the picture over time. But if you were a giant looking down at the page, you did see the whole dragon at once. Wheeler and DeWitt are telling us to be the giant, not the ant. Look at the whole page. It is all there. It is timeless. Let us go back to the weird way things move in this timeless world. In our world, movement is smooth. You slide, you walk, you flow. In the quantum world, movement is jerky. It is a series of teleports. This is called a quantum jump. Imagine a tiger in a jungle. It is sitting under tree A. It wants to go to tree B. In the real world, it walks. In the quantum world, the tiger disappears from tree A and instantly reappears at tree B. It never existed in the space between the trees. It didn't fly through the air, it just vanished and materialized. This is exactly what electrons do when they change energy levels in an atom. They teleport. Crucially, this jump takes zero time. It is instantaneous. If you can move without time passing, then movement isn't really the right word anymore. It is more like switching channels on a TV. You are watching channel 4, then click. You are watching channel 5. You didn't travel through the static between the channels. You just switched states. If the universe is built of these jumps, then maybe the flow of time we feel is just an illusion created by billions of tiny jumps happening really fast. It is like a movie. A movie looks like smooth motion. But if you look at the film strip, it is just a bunch of still photos. Photo 1 arm down, photo 2 arm middle, photo 3 arm up. When you flash them fast, it looks like the arm moves. But in reality, nothing moved. There are just These are just separate static pictures. The universe is a film strip of quantum jumps. Nothing flows. It just switches from snapshot to snapshot. The universe isn't just random jumps, it is a playground of choices. Imagine a jungle gym, those climbing frames at the park. But this one has a rule. Some bars are very thick and easy to grab, and some are rather thin and hard to see. When a quantum particle, let us call it a quantum kid, needs to decide where to go next, it looks at the bars. The thick bars are high probability, the thin bars are low probability. The wave function we talked about earlier determines the thickness of the bars. It makes it very easy for the kid to climb to the next moment where the ball stays on the table, and very hard to climb to the next moment where the ball suddenly turns into the frog. The path to the frog ball is there, a very thin bar, but it is unlikely the kid will grab it. This whole structure exists at once. The entire jungle gym, with all its thick paths and thin paths, is still there. The future is just the bars that are further down the line. They are already built. The past is the bars behind you. They are still there too. The choice isn't being made in real time. The options are just weighted differently. The quantum kid doesn't need a watch to climb. The structure dictates the flow. It is like a marble run. You drop the marble and it follows the track. The track is the timeless shape of the universe, guiding the motion of reality along probable paths. This slide brings us to the most beautiful idea of the theory, the timeless jungle. Imagine a beautiful, dense rainforest. It is full of life, vines, monkeys, and waterfalls. Now imagine you could take a magical photo of this jungle that captures absolutely everything in three dimensions. Every leaf, every drop of water, every hair on the monkey. In that snapshot, is the waterfall falling? No, in the snapshot, the water is hanging in the air. Is the monkey swinging? No, it is frozen mid-air. Yet the jungle is still real. It still exists. It has complexity and beauty. The Wheeler-DeWitt universe is this three-dimensional snapshot. It suggests the universe is a configuration. It is an arrangement of stuff. It isn't a happening. It is a state. The clocks in this jungle are just objects. A clock on the wall is just a circle with hands pointing at numbers. It doesn't measure anything in the snapshot. It is just a piece of furniture. If you have a collection of these snapshots, trillions of them, and you stack them up, you get history. But each individual slice of the universe is purely timeless. It is just space and matter arranged in a specific way. This is the zero energy universe. It is waiting to wake up, but it never really needs to. It can just exist as a magnificent, silent painting of a world. The monkey doesn't mind, the water doesn't mind. They are perfectly content being frozen in the eternal now. So, if everything is a frozen cloud of possibilities, how do we get one single reality? How do we get one puppy instead of a cloud of puppy robots? This is the mystery of observation. Imagine a gift box. Inside, the box is in a quantum state. It contains a puppy and a pirate hat and a robot all mixed together in a fog. It hasn't decided what to be yet. It is all of them. When you, the observer, walk up and tear open the wrapping paper, the fog vanishes. The universe is forced to make a choice. Suddenly, there is a puppy. The pirate hat and robot disappear as if they never existed, or they exist in another world, but we will get to that. This act of looking is what sharpens the fuzzy cloud into a hard reality. In the timeless universe, this looking is what creates the illusion of a specific movement. The box is the wave function, the map of possibilities. The open box is the collapsed reality. We are constantly opening boxes. Every time you open your eyes, you are forcing the universe to decide. Is the sky blue or grey? Is the cat asleep or awake? The universe snaps into place because you looked at it. Because you looked, it was just a hazy. Before you looked, it was just a hazy list of options. Observation is the magic key that unlocks a specific story from the library of all possible stories. Let us make that box opening even simpler. Think of a balloon animal. But this isn't a poodle or a sword yet. It is a weird, wobbly blob of balloon that looks like everything and nothing. It is a generic maybe shape. This blob is the quantum cloud. It holds the potential to be cat, dog, or sword. It is 60% likely to be dog, 30% likely to be cat, and 10% likely to be sword. Now you take a needle. The needle is in your hand. It is the act of measuring. You poke the blob, or rather snap. It doesn't burst into nothing. It snaps into a specific shape. Suddenly you are holding a balloon dog. The wobbly blob is gone. You can't go back to the blob. You have collapsed the wave function. You have chosen a reality. In this physics, the universe is a sea of these wobbly balloons. They are floating around, undefined, waiting for an interaction to define them. When particles bump into each other, they poke each other into shape. The Wheeler-DeWitt equation describes the wobbly balloons. It describes the universe before the poke. It describes the pure potential. Once the poke happens, we enter the world of events and history. But the underlying reality is the wobbly, timeless blob of potential. This is the biggest argument in the quantum playground. Who holds the needle? Who decides what the universe looks like? There are two main teams here. On the left, we have Miss Universe. She represents the idea that the universe pops into its own balloons. This is called self-collapse or intrinsic collapse. It means that when a blob gets too big or too heavy, it just snaps into a shape naturally. Gravity might pull it into reality. It doesn't need a human to look at it. The universe decides without us. On the right, we have the kid scientist. This represents the idea that consciousness or measurement is needed. This theory says that if no one or nothing interacts with the system, it stays a blob forever. A tree falling in the forest doesn't make a sound if no one hears it. In fact, it doesn't even fall, it just remains a falling, standing, ghostly tree until a squirrel or a person sees it. Then there is the scale in the middle. We don't know for sure which is true. Maybe it is a mix. Maybe big things like planets pop themselves, but tiny things like electrons need us to look at them. The thought experiment shows a kid covering their eyes. If you cover your eyes, does the room disappear? In the quantum world, the room might actually blur out into a cloud of maybe furniture until you peek again. It is a fun, slightly spooky game of peekaboo with reality itself. Now we need to do a little bit of cloud math. Don't worry, it is not numbers, it is pictures. In the Wheeler-DeWitt world, we talk about superposition, which is adding things together. But we aren't adding physical objects. If you add one apple to one apple, you get two apples. That is normal math. In quantum math, if you add a cat cloud, a possibility of a cat, to a dog cloud, a possibility of a dog, you don't get a cat dog monster. You get a pet cloud. You are adding probabilities. You are stacking the chances up. Imagine you have a stack of pancakes. The higher the stack, the more likely you are to be full. Here, the height of the cloud represents how likely something is to happen. If we have a huge cloud of puppy possibility and a tiny wisp of dragon possibility, the puppy stack is taller. When we blend clouds, we are mixing different histories of the universe. The universe is a mix of universe with life, cloud, and a universe without life, cloud. They overlap. The Wheeler-DeWitt equation tells us how these clouds sit on top of each other. It's like mixing paint colors. You mix blue and yellow to get green. The green isn't blue or yellow, it is a new state. The universe is a green state made up of all the possible blue and yellow histories mixed together in a timeless suspension. This slide explains the equation without the scary algebra. Think of the universe as a song, but it is a very strange song. It is a song where all the sounds cancel each other out to make perfect silence. The equation h psi equal to 0 has a 0 on one side. That 0 is the silence. The other side has all the notes of the universe: stars, planets, matter, gravity. We assign symbols to these things. A star is energy, the loud trumpet. A planet is gravity, the deep bass. A cookie is matter, the steady drum. The wave is the shape, the melody. The rule of the timeless universe is that when you play all these instruments together, they balance perfectly to 0. The positive energy of the stars and cookies is exactly equal to negative energy of gravity. It is like digging a hole. You pile the dirt up next to the hole. The pile is the mountain, positive energy. The hole is the valley, negative energy. If you shovel the dirt back in, the ground is flat again, 0. The universe is just a separated hole and pile. The nothing separated into something and anti something. So the total sum of the universe is still nothing. It is a glorious, complex, beautiful form of nothingness. That is the harmony. The silence is made of noise that cancels out. Let us visualize that balance. Imagine a seesaw. On the left side sits a big round 0. It is heavy, solid, and still. On the right side, we pile on the entire universe. We put on the energy, represented by glowing ghosts, gravity, represented by heavy weights, and stuff, represented by cookies and rocks. Amazingly, the seesaw stays perfectly level. It balances. This is the zero energy universe hypothesis. It answers the question, where did all the energy come from to make the Big Bang? The answer is, it didn't come from anywhere because the total amount is still 0. You didn't need to steal energy from a bank. You just split the 0 into positive and negative. The taste test shows this well. Imagine a glass of water that is neutral, flavorless. That is the 0 universe. Now imagine you separate the water into a spoon of pure lemon juice, sour or negative, and a spoon of pure sugar syrup, sweet or positive. You have two very strong flavors now, but if you mix them back together perfectly, you get the neutral water again. The universe we live in is the separation of sweet and the sour. We live in the sugar syrup and feel the lemon juice as gravity, but the whole glass is still just water. It creates an active zero, not an empty zero. If the universe is a frozen zero, why do we have clocks? Why do we feel time? This is called emergence. It means a pattern that appears when you have enough small things working together. Think of fireflies. If you have one firefly, it flashes whenever it wants, randomly. There is no rhythm. But if you have 1,000 fireflies and they start noticing each other, they sometimes synchronize. They all flash at once. Suddenly there is a beat, there is a rhythm, there is time. The individual firefly didn't try to make time, the group made time. Time is a behavior of the crowd. Think of an audience in a stadium. Before the show, everyone is chatting, it is just noise. Then people start clapping. Slowly, the clapping syncs up. A beat emerges from the chaos. In the Wheeler-DeWitt theory, time is like that clapping. It isn't a fundamental rule of the universe. It is just what happens when enough matter and gravity interact in the right way. They agree on a sequence, and that agreement feels like a ticking clock to us. But underneath, in the quiet dark, the individual pieces are still just timeless flashes. So we have this weird timeless world and our normal ticking world. How do they fit together? We call this the semi-classical view. It is like mixing two types of toys. You have your old school wooden blocks, classical physics. These are reliable, solid, and stay where you put them. This is how planets orbit the sun. Then you have the new glowing, floating magnetic blocks, quantum physics. These are wild and unpredictable. The Wheeler-DeWitt universe says that we can build a bridge between them. When the quantum clouds, the floating blocks, get big enough and flat enough, they start to act like wooden blocks. They settle down. They mimic the old rules. It is like using both types of Legos in one castle. The foundation is made of the weird quantum stuff, shifty and timeless, but as you build up, the towers are made of the solid classical stuff, stable and timed. We live in the tower, we look around and say everything is solid, time is real. But if we dig into the basement, the foundation, we find the weird glowing blocks that don't make sense. The semi classical approach is the handshake between the ghost and the machine. It says both are true in their own place. Let us test this time is a story idea. Imagine every clock in the world disappeared. Every phone, every wristwatch, every wall clock gone. Would time stop? No. Your heart would still beat. The earth would still spin. The galaxy would still rotate. We could use your heartbeats to measure the day. I will meet you in 5,000 heartbeats. This proves that time is just a comparison of repeating patterns. We compare the spinning hand of a watch to the spinning of the earth. We compare the beating heart to the walking feet. Any repeating pattern can pretend to be a clock. Wheeler and DeWitt remind us that we don't need a master time dimension flowing in the background. We just need things to move relative to each other. The galaxy is a clock. An atom is a clock, a heartbeat is a clock. Time is just a handy story we tell to relate these motions. It is a correlator. It connects the galaxy's spin to your breakfast time. But underneath, the universal cloud is still. It is like a movie where the characters check their watches, but the DVD itself isn't wearing a watch. The characters have internal time, but the DVD has external timelessness. We are measuring our heartbeats inside the frozen DVD. We are back to the map, but now we are asking a question, where are we? The Wheeler-DeWitt wave function gives us a probability fog. Imagine you release a helium balloon which represents our universe. Where will it land? The map shows a big area called school. This area is huge and clear. There is a 70% chance the balloon lands here. This represents a universe like ours, one with stars, planets and laws of physics that makes sense. Then there is a smaller area called lake, 25% chance. This might be a universe that is a bit weird. Maybe gravity is weaker. Then there is a tiny spot called moon, 5% chance. This is a crazy universe where atoms never formed. The wave function is the fog that covers this map. It tells us the density of the chance. It tells us that we are most likely to find ourselves in a normal universe, that is school, but the other universes exist as possibilities in the fog. We are playing a game of chance. The universe plays this game. It distributes its existence across these probabilities. We woke up in the school outcome, but the math says the moon outcome is still hovering there in the equations, just very faint and ghostly. This leads us to the most famous mind bender, many worlds. If the map has a spot for chocolate and a spot for vanilla, and the universe doesn't choose until we look, maybe it never chooses. Maybe it does both. Imagine you are at a snack stand. You can choose chocolate or vanilla. In the Wheeler-DeWitt view, the universe splits. In one branch, you pick chocolate, you eat it, you are happy. In the other branch, you pick vanilla, you eat it, you are happy. These two yous are now living in separate realities. They cannot talk to each other. They are like two radio stations broadcasting on different frequencies. The slide shows a rocket swing world and a bubble slide world. The math of quantum mechanics keeps track of both. It doesn't throw the unchosen one away, it keeps it. This means the universal wave function is a collection of infinite branches. Every decision, every coin flip, every electron jump splits the world. This sounds like science fiction, but it is the cleanest way to solve the math. If time doesn't exist and everything is a static object, then the object is a giant tree of all possibilities. The tree has a chocolate branch and a vanilla branch. Both branches exist on the tree simultaneously. You just happen to be climbing the chocolate branch right now. How do we count these ghosts? How do we know if we are the 70% chance or the 5% chance? We use a rule named after Max Born. It is called Born's rule. The slide uses a candy jar analogy. Imagine a jar full of ghost marbles, probabilities. You can't see them clearly. They are just a fog. Born said, if you want to know how likely something is, look at the height of the fog, the amplitude, and square it. To square something means to multiply it by itself. 2 times 2 equal to 4. 3 times 3 equal to 9. This is the candy counting rule. If the cloud is 2 units high, you don't get 2 candies, you get 4. A 2 by 2 square. If the cloud is 3 units high, you get 9 candies, a 3 by 3 square. A small increase in the cloud height means a huge increase in the probability, the number of candies. This is why some things in the universe are super likely and some are super rare. The probability grows explosively. This rule helps us predict where the electron will pop up. It tells us to bet on the tall clouds, because when you square a tall number, you get a giant number. The ghost marbles turn into real, countable candies only when we look, and this rule tells us how many we will find. Let us cook this idea. Imagine the quantum wave function is cookie dough. It's a blob. It doesn't have a shape yet. It isn't a cookie. It is potential cookie. You put this blob into the oven. The oven is the observation machine. It cooks the dough into a specific state. When you open the door, you find distinct crispy cookies. Some have 2 chocolate chips, some have 5, some have 10. The Wheeler-DeWitt equation describes the dough. It describes the raw material before it is cooked into reality. Once you open the door, you are dealing with the collapsed state, real cookies. The graph, the histogram, shows how many chips are on the cookies. Most cookies have 5 chips, the tall bar. Very few have 10 chips, the short bar. This is just like the school versus moon map. The universe is mostly average cookies, but if you bake enough of them, if you look at enough universes, you might find a rare 10 chip jackpot universe. The connection is the universe exists as dough, timeless, formless, until the oven of interaction bakes it into a crispy moment of now. Here is a fact that will melt your brain. Light is timeless. According to Einstein, if you could ride a beam of light, time would stop for you. For a photon, a particle of light traveling from a distant star to the eye, the journey takes 0 time. It leaves the star and hits your eye instantly from its perspective. The slide shows a baby universe on the left and you on the right. There is a wavy line connecting them. This light from the Big Bang, the cosmic microwave background, is still hitting us today. The Wheeler-DeWitt equation describes the baby universe. It describes the conditions of the cosmos before any clocks started ticking. So this light is a messenger from the timeless land. It has traveled through the emergence of time to reach you. It connects the nothing to the now. Kids can draw a wavy line from an imaginary baby universe to their bedroom. That line is a real physical connection. The oldest light in the sky is older than the concept of time itself in the emergent sense. It is a relic of the frozen crystal universe streaming into our moving world. Can we use this for something cool? What about your brain? Your brain is made of atoms. Atoms follow quantum rules. Atoms teleport and tunnel. Does your brain use quantum jumps to think? This is a controversial but exciting idea called quantum consciousness. The slide compares a classical brain to a quantum brain. A classical brain is like a slow march. Signals have to walk down the wire of the nerve, one step at a time. It takes time. A decision is a process. A quantum brain would be like a flash. The signal could tunnel through the barrier. It could jump from idea A to idea B instantly without going through the middle steps. This might explain why you sometimes have a eureka moment where the answer just pops into your head. Maybe your thoughts are surfing the timeless wave function. Maybe your imagination is accessing the possible clouds before they collapse into real words. If your brain can tap into the timeless layer, then your thoughts are faster than clocks. It is a superpower explanation for human creativity. We don't know if it is true yet, but it is a possibility hidden in the math. If there is no time, did the universe have a birthday? Did it start? This is the moment zero problem. The slide offers different pictures because we don't know the answer. Sudden pop, the Big Bang was an explosion. The classic theory. Gentle bloom, the universe opened up like a flower, smooth and quiet. Eternal loop, it is a snake eating its own tail. It never started and never ends. Turtle stack, it is universes all the way down. In the Wheeler-DeWitt view, origins are just one edge of the shape. Think of a ruler. It has a start at 0 inches and an end at 12 inches. But the ruler exists all at once. The 0-inch mark isn't happening before the 12-inch mark. They are just different spots on the wood. The Big Bang is just the 0-inch mark of the cosmic ruler. It didn't happen in the past. It is just the edge of the geometry. The cake is sitting there with the candles unlit and lit at the same time. The beginning is just the coordinate, not a date on a calendar. Now we get hands on. How do we play with this? The forever spinner. A top that spins. If you squint, the spinning top looks like a solid blurry shape. That is the electron cloud. It is motion creating a static shape. The wave stacker blocks that are curvy. You can only stack them if the curves match. This shows how waves decide structure. The quantum kaleidoscope. You look in a tube and see a pattern. The pattern is symmetrical and still, but it is made of mirrors. It represents the many worlds reflected over and over. The puppet in the fog. A puppet made of cotton balls. You can't see exactly where the hand is. It's a probability puppet. The overlap puzzle. Clear plastic sheets with drawings. When you stack them, they make a picture. This is superposition. All the layers exist, but you need to look through all of them to see the reality. We end where we begin, with the coloring page. The slide invites you to the observer. You have a blank planet. It is in a superposition of all possibilities. It could be a water world blue, a forest world green, or a lava world red. When you pick up a crayon and color it, you are doing the job of the universe. You are collapsing the wave function. You are making a choice. You are turning the timeless potential into temporal reality. The takeaway is that you are part of the equation. The universe isn't just a movie you are watching, you are the projector. Your observation, your interaction, and your existence are what gives the timeless ghost its solid form. The universe is a coloring book, and you are the artist bringing time to the timeless. So, the next time you look at a clock ticking on the wall, remember that it might just be a toy measuring a game that doesn't really exist. The universe is a vast, beautiful, frozen ocean of all possibilities, waiting for you to dive in and make a splash. Time is just the ripple you leave behind.